All right, so just a little quick review. We have a weak acid in a container, and we're going to titrate it with a strong base because we want to identify what this weak acid is. And this is kind of like following or trying to use the, what do we call this? Let me get to,
It was the unknown weak acid problem.
okay, the unknown weak acid problem for the lab final exercises. All right, unknown weak acid, where is it? There, right there. Very good. Okay, so when you titrate an unknown weak acid, what's going to happen with a strong base, and you have to use a strong base like sodium hydroxide, what's going to happen is if you look at the pH versus the concentration or the amount of sodium hydroxide that you add, then you're going to see this sort of a curve, where this is our point where the acid has all been consumed. Okay. Well, if you look at that point as the end point when the acid has all been consumed and look at halfway to that point, this point right here, halfway, is the scenario where your acid, so let's say our acid is called HA, and the reaction that's occurring here is we're adding hydroxide ion to HA. Do you think you could predict the products of that reaction? Acid with hydroxide ion, what would their products be?
Is that what HA means?
Yes.
Oh my goodness, that was in every equation I was looking at on how to find HA. Okay.
It's like some generic acid, right? Because acids start with H and then just the rest of whatever the acid is.
Okay.
Okay, so what would our products be, do you think?
HOAH.
Well, the hydrogen here is going to get taken away by the hydroxide ion, right?
Mm-hmm.
And that forms what? H2O. And what's left behind?
The acid.
The acid with a negative charge. Okay? So as the hydroxide is added, the hydrogen from the acid is removed and leaves behind the rest of our acid without the hydrogen. Okay? We call that the conjugate base. We haven't introduced that term, but that's what we call that. But the rest of the acid without the hydrogen, or the conjugate base, its concentration increases as you add more and more base. And when you get to this point that all of the HA is gone, it's all been converted to A minus, right, at this end point. But when you're halfway in between, when you have a lot of your HA, well, half of it, converted to A minus, but you still have half of your HA left, there's a special scenario that occurs in which you have a specific pH. And that pH is dependent on what that acid is, and we call that pH the pKa. pKa. The pKa is a special pH for a given acid. All right? It's the pH that will result when half of the acid is with its hydrogen and the other half is without. So if you have a solution where half is with its hydrogen and half is without, then you'll be at that special pH, which is called the pKa. Okay? So let's look at your desktop now.
Okay. Back to the
unknown weak acid problem. Not the next one over. There we go, yeah. So, and then scroll up just a little bit, and it shows us the 6 different possibilities, right? Those are the pKa's of the 6 different acids, right? So yes, when we reach that pH for whatever the unknown acid is, theoretically, that would mean we're halfway there. Now, we don't know how much acid there is for each one. We don't know the concentration, but we can start. Why don't you pull a Erlenmeyer flask out? Okay, and pull out our unknown acid. Very good. Why don't you pour into that flask maybe just a half a milliliter, so 0.5. It's nice that we have the precise button. Very good. So we have a half a milliliter in there. Very good. So now let's get out a burette and some sodium hydroxide. Okay, let's put some sodium hydroxide in that, strong bases. Let's try the 0.1 molar sodium hydroxide. What did you get? You got the 1 molar. That's fine.
I got one.
Okay,
Okay.
so let's start off with that. Let's put that into the burette, about 52 mils. Very good. And now, bring down your flask that we're going to, did you fill it up? I didn't see.
Yes.
Yeah, okay. Okay, let's put it in there to the acid, right?
Do I need to? Oh wait, there's not an indicator.
Yeah, like you said, there's no indicator. So there we go. Now, what we're going to do is, let's just try 1 milliliter to start off with. And say pour, right? Oh, now stop. Now you see to the left there, it says the pH. Did you just add another milliliter or no?
No, I've only added one.
Okay. It says the pH to the left there. You see that? 13.66?
Yes, sir.
All right. So that's very basic, right? The pH of the base, click on the base by itself over there and it'll tell you the pH. It's at 14. So essentially we've added so much base that all it's measuring is the excess base that we added.
Mm-hmm.
So let's try again. This time we're going to get out a new Erlenmeyer flask. Put some, this time let's put in, instead of a half a milliliter of the unknown acid, why don't we put in 10 mils? Okay? And now we can titrate with that same stuff. Let's see, we're at 1 milliliter. All right, let's just add 1 milliliter at a time. Let's see how the pH is influenced. Okay, so it's 6.05 already. So try again, 1 more milliliter. 6.48. So go up to those pKa's up there. So we're already past all of those pKa's. Does that make sense?
Except the all.
Oh yeah,
I
you're
don't know
right.
how to.
All oxalic acid.
Yes.
All right. So let's add. Right now we're at 2 milliliters. I'll keep track of how many milliliters. Well, it's just one less than what it says, I guess. How about instead of adding a milliliter, this time add a 0.1? Okay, 6.52. Now let's keep adding 0.1 milliliters until we get to the pKa of the aloxonic acid. Aloxonic acid. What was the pKa again for the aloxonic acid?
6.64.
Okay, let's see how much it takes to get to the 6.64. Oh, okay. Why don't you try to add 0.01 now?
There we go.
So that was 0.02 then that we added?
Yes, sir.
And it says right there 12.420 milliliters in the 250 milliliter flask. You see that part?
Yes.
And we started off with 10 mils, correct?
Yes, sir.
So at 2.420 milliliters of the 1 molar, right?
Mm-hmm.
We got to our pKa. So let's slowly add up to twice as that amount, which would be 4.84 milliliters, and see if that gives us our endpoint. Okay?
Okay.
Do you understand why we're doing that?
To see if the curve follows the right pattern.
Yeah, because I mean, if this is the pKa, if we're at the pKa right now, then theoretically at 4.84, exactly twice this much, we should be at our endpoint, right?
Yes.
All right, it's going to take a little bit. It'll be 5.84 on your burette there, right?
Mhm.
So maybe we start adding in 0.1 instead of 0.01, so it goes a little faster. Okay. Okay, hold on just a second. So we said that it should be at where?
14.8.
14.84, that's right. And on your thing, it's going to be 5.84, right?
Yes.
Okay. So go ahead. It's the pH is changing kind of quickly now. So, and especially when we get above 7, we expect it to change probably really fast now because all the acid is probably consumed. So go ahead. All right. We're at 4.220. Let's try to,
Yes.
let's add point, oh wait, we said 4.84.
Yes, sir.
Let's add, how much do we want to add? We want to end up right at 4.84, and we're at 4.22. So maybe we got to add 0.02 to get it 4.24. Does that make sense?
Mhm.
Okay, let's try that. All right, now we just need 0.6 more. So let's just go in 0.05 increments.
Oh, I already went one past, I think.
I think
Because I
you're right.
went to.
Well, oh, you
Oh,
did.
okay.
You did, yeah.
I went one
So
more.
keep going until we get to 0.34. There we go. Now we need to go to 4.84. So how about 0.05? Okay. Okay, hold on just a second. I think it's pretty clear that it's going to happen. So 4 point. Yeah, I think we already know. Anyways, yeah. So go ahead and go one more. Or actually, how many do we need? 2 more? Oh, that's
No,
where.
that's right.
That's it right there, huh? So we were exactly at our pKa at 2.42 milliliters and 1 molar. Is that true?
Yes, sir.
Okay. So that means we were exactly halfway at 2.42 milliliters and 1 molar NaOH. That essentially, I think, I mean, yeah, I think that's all we need. Try to go just a little bit more, and the pH should now go up to 10 really fast. Try to add just a couple more aliquots of the 0.05.
Okay. Oh,
Yeah. There we go. Is that 1 more or is that 2 more?
that was 1.
Yeah, there we go. For sure. Okay, so at 2.420 milliliters, 1 molar, we were right there. So let's do some calculations.
Okay.
All right. Do you want to go to my page now?
Yes. So, how do you know if that was right? Just because of the rapid increase afterwards?
Yeah, that's right.
Okay.
And all you really need is the volume, 2.42 milliliters of 1 molar to get to the pKa. Right?
Okay. Mhm.
Okay. Now we want to know what the molarity of, we know the acid was alexonic, is that what we call it?
Yes.
We want to know the moles of that acid per liter of solution. So, what are we going to start with over here?
We could start with the amount of NaOH needed.
Okay, can I convert it to liters? 0.002420 liters. Is that okay?
Yes, sir.
And then we go from liters of sodium hydroxide to what?
Molars
Uh-huh.
or moles.
I want to say moles of the acid over here. Okay, so moles of the NaOH. You know how we do that?
Isn't it just 1 mole because it's a 1 molar solution?
That's right. Very good. And then moles of sodium hydroxide to moles of our acid.
How do we know? Do we just know it's a single, really like a 1-to-1 ratio?
No,
Or
that's a good question. Let's see if we can. What's the name of that acid again?
I looked it up. It's really long. It is. Let me look. Alloxanic. Alloxanic.
Okay. Well, we know it's 1 molar, or we know it's a 1-to-1 ratio because we just did the titration and we saw the curve, right? We saw our curve that looked like this, right? And we got to the basic. If it had been 2-to-1 ratio, it'd have 2 bumps like that, right?
Oh, okay.
So we know it's a 1-to-1 ratio. But I was just looking up here just to try to find a reaction. That doesn't look like the right word, titration, right? Whoops. Yeah. So here it is. And all this is showing us is that this is the hydrogen that's going to come off.
Mm-hmm.
But, yeah, so we have a couple of ways of knowing it's a 1-to-1 ratio. The best one is just knowing that our acid titration looked like this. We saw 1 bump, not like this, right?
Mm-hmm.
We could look into it more online and see that value or that molecule, what it looked like, and what happens when it reacts with sodium hydroxide. But this is enough. Okay, so then we just need our liters of our acid down here, right?
Mm-hmm.
How many liters was that?
Do we do it to the halfway point or the all the way point?
To the all the way point.
Okay, so that was
This was the liters of the base, right?
yes. Okay.
But what one was this? This is the liters of the acid. Do you remember how much acid we did?
Oh, how much we put in?
Yeah.
I think we started with, oh gosh, I don't know, really. We started with 10.
Yeah. Okay. Calculator.
I have one.
Oh, good. Can't find my calculator. Where would my calculator go? Did I take it home? Where's my calculator?
I got 0.242.
Any other significant digits?
No, just that many. Because I think it just,
Yeah.
from the first unit,
Okay. Well, should we give it a try? Why don't you go back there and give it a try?
Okay. All of my other options.
You have the correct acid, but the concentration is wrong. Try it again with smaller additions of base. Okay, so it's saying that our, let's see, did we do it? Make sure we didn't miss something here. 0.242. Go back to our, well, let's just bring up another sample here. Now we know the concentration is, well, it's got to be really close. It's got to be really close. So we know the concentration is 0.242. Let's, if we dealt with 0.1 molar instead of 1 molar, 0.1 molar sodium hydroxide, and we put in 10 milliliters, then we would expect our pKa to occur around 10 milliliters, or a little bit more actually, like 12 milliliters, right? So let's try that.
So I use the 0.1 molar.
Yeah, let's get a new burette. Actually, you can remove the whole, right click and remove the whole, okay, there we go.
I'm still in class. Okay. And then, should we do 10 milliliters again?
I think so, because if we do 10 and we use the 0.1 molar, it would take twice as much of the base to get there, right? But we're only going halfway, so.
Okay. And then the strong base is the 0.1.
Silly thing. I can't figure out why it sometimes does that. Is it because there's something in the corner there or something? I don't know. That doesn't always do it.
It's this corner.
All right, here we go. So what's our pKa again?
Our pKa is 6.64, I think. Yeah. So since it's 0.1, shouldn't it take a lot more to get it to react?
Yeah. So theoretically, we from our concentration of should be pretty close to 0.242. I don't know what happened, why we didn't get it, but should be pretty close to 0.242, maybe like 0.243 or 0.241. I'm not sure, but or actually, let's see. Anyways, we should take about. So if it was 0.24, it would take 24 milliliters.
Okay, so I could start adding.
Yeah, so I think we should be seeing our pKa around 12 milliliters. 12.1 about. So.
Okay, so I'll start by adding 1 till we
Okay, all right. What's our pKa again? 6 point what?
6.64.
All right, let me write that down. All right, 6.64. Okay. Okay, go for it.
Oh, that increased really fast. Should I lower this?
I think we're okay. Keep going.
Okay.
Okay.
Did I change to like 0.2 or 0.5?
Well, try 0.5. Okay, try 0.1 now. Okay, be patient. Make sure you give it time to equilibrate after each one. Okay, go ahead, keep going. Okay,
Okay, there.
24.2. Is that exactly what we had before?
Yeah,
Okay, did we do our calculation wrong?
maybe. Let me try it again. So,
Let's see. No, we couldn't have done our calculation wrong.
that's with the 0.1 molar. So, it's almost the same problem.
So we got 0.0242 liters times 0.1 molar divided by our 0.01.
Yeah, I got 242 still.
Let me see, get my calculator up here. What? All right. 0.0242 times 0.1 divided by 0.01. 6.64. Try adding 0.02 or 0.01. Try adding 0.01.
Okay, to the answer?
Yeah, no, to the try adding just a little more base, 0.01 to the base instead of 0.1, 0.01. Yeah. Go ahead. Did you?
I did. I've added it twice.
Okay, good. Keep going until we get to 6.6.
Just
6.65.
okay.
Let's find what the last one is before 6.65.
There it is.
Okay, so that's 24.43. Or no, yeah, 24.43, right?
Yes, sir.
Okay, so the first one was 24.2, and the last one is 24.43. What's the average of those two?
24.2 plus 24.315.
All right, so then the concentration would be 0.243, right?
Mm-hmm. Should I try that?
Sure.
It's wrong. It says it says it's 486. I think it wanted the
Oh.
final.
What?
I think it wanted the final.
No, yeah, we were stupid. Of course. We don't want the halfway. Nuts.
Okay, as long as I know how to do it, I can do it again.
You understand why, right?
Yes, sir.
Because well, should we do it again, or you got to get going?
It's okay. I think I got it. And if I don't get it, I'll ask you tomorrow in lab.
Okay. All right.
Thank
Yeah.
you so much.
Sorry about that. We were so darn close, but yeah, I don't know what I wasn't thinking. Of course, we want to go to the end point. We don't want to go to the halfway point, right? Does that make sense?
Yes, sir.
Okay.
Thank you so much.
All right. Sorry about that.
No, thank you.
Okay.
Have a good one.
You too. Bye bye.
Bye.